In this problem, we're going to have two groups, and we're going to do a hypothesis test conclusion two ways, formally and informally. Here we're trying to test to see if the proportion of college students that drive SUVs differs from the proportion of college students that drive compact cars. Starting with setting up the hypotheses. The null hypothesis for this is always an equal statement. So in ours, our null hypothesis is that the proportion of maybe sub S for the SUV drivers is equal to the proportion of C compact car drivers. And then the alternative statement is based on one word and one word only. It's either a less than, greater than, or in this case, it's the word differs. Differs is the key word. So differs would indicate copy and paste P sub S, P sub C, but stick a not equal sign. Not equals means differs. To the side, just so we're clear on what's being said, let's interpret each one of these real quickly. The statement here in the null hypothesis simply says the population proportion, that's why they don't have hats, because it's for the population proportion of college students driving SUVs is the same as those driving compact cars. The beauty about this is that once you have that statement, the alternative statement is very easy because you can modify the one that you wrote for the null. So it'll look the same. The population proportion of college students driving SUVs now is not the same. We would say differs from those driving compact cars. So some books say differs, some books uses the phrase evidence against. Just depends on what you're doing. That gets us set up. Now, we would get a sample. The sample would create a p-value. So let's suppose that ... all of a sudden, our sample that we get of college students ends up turning out a p-value equal to 0.0015. What I'd like to do is turn that into a percent, just for the sake of simplicity. So, or you could think about this as a percent by moving the decimal over 2 spots. If you move it over 2 spots, this is like 0.15%. Now, the two ways that were mentioned in the other videos on how to conclude, you can either make a formal conclusion or an informal conclusion. So for the formal case, we need to use some value of alpha. So let's make a formal conclusion, and maybe we'll use alpha is equal to 0.1. Let's start off with that and just get a feel for how this would work. So in the formal conclusion, give ourselves a little bit of space here, and we'll let using some value of alpha. Watch what happens. Let's let alpha be equal to 0.1. This, of course, is 10%, right, if you move the decimal over. So if you made a little graph like we did in the other videos, you're going to put a little mark here at the 10% value of alpha. Over on the far left is 0. The question is our p-value indicating that we are falling in this green zone to the left of 10%, or are we falling in the red zone to the right of 10%? Well, take a look. Our value that we got here is clearly the value 0.15%. Where is it? It's super close to 0%. What does that put us in? Well, the green zone, we said, is the rejection zone. Reject the null. So what we would say is this. We would reject the null at the alpha is equal to 10% level. So that's the way this conclusion would work if we're going to use the 10% business. Now, what if they decided not to use 10%? What if they decided to change this on us? Well, let's play the game still. We can still do a few of these with the formal. Maybe instead, alpha would be equal to 0.05. So the same setup applies. This time we make our bar over here. 5% puts us about right here. 0% would be there. And again, we're asking, where do we fall in this little zone? Well, we fall really close to this spot here, which still puts us in that green rejection zone. So as we keep testing this, we're seeing that we're still in the rejection zone. So formally, we'll still reject at the 5% level. So reject the null at the alpha is equal to, you could say 5%. You could say 0.05. It's the same thing. Fractions and decimals and percentages are interchangeable. And then the most common ones that we talked about, 10%, 5%. The only other one that would be super common that you might see, you might even see this down to a 1% alpha level. We can do it for fun. If we did that, we draw our line. Once again, 0 is right here. And now 1% is really tiny. The 1% level is about right there, even though we're tight at the space on here. And once again, 0.15, it's even tinier than 1%. It's not even a full percent. Where does it put us? Once again, this one happens to put us in the rejection zone. So we would even reject this at the 1%. So because we had a really small value for the p-value, we end up rejecting the null hypothesis for the three most common values of significance. Alpha is called the significance level. So we rejected it in all of the cases that are here. And sometimes you'll reject at one level, but you won't reject at the others. But when the p-value is teeny tiny, you'll end up rejecting at all three of these common levels of alpha, or what's called significance. Now, how does that compare to what we would do if this were going to be an informal conclusion? Well, the informal conclusion I kind of like better because it tells us a little bit more information about our feelings of what's going on in the problem. Why? The difference between the informal and the formal. The formal conclusion is a little light switch. It's a toggle switch. It's either you rejected the null or you didn't reject the null. Those are the only two things that happened. In the informal conclusion, we actually get a gauge, and I love the gauge. The gauge is very nice about directing us on the wording that we would use and how we would interpret this in the real world. So as we throw our gauge up here, we said we've got 0, somewhere we would have 1%. 5% is the next tick mark, and then 10% was the other tick mark. And we colored these zones before. We said anything falling in the green zone, we labeled as very strong, so I'll just abbreviate it. The next zone on the video we did earlier was yellow, which is just a horrible color, but at the same time, it serves a purpose here. So above it, we'll write the word strong zone. We'll put it in black so it's more legible. The next zone, anywhere between 5% and 10%, is some. And anything that goes to the right of 10%, we keep it in red because we said there is no. No what? What are these words? These are adjectives describing how strong is the evidence towards your alternative. So this is a discussion of the evidence for favoring the alternative hypothesis. Where do we want to put our p-value? Well, we saw where our p-value was. Our p-value, 0.15%, teeny tiny, puts us right there. That's where the p-value is. So we are definitely in the very strong zone. So here's the way we would interpret this. This is where this comes in really nice. We would say there is very strong, that's from that region in green, very strong, statistically significant evidence. That's the type of evidence. And then the next statement is always about the alternative. What was our alternative? Well, go back over to the problem. Population proportion of college students driving SUVs differs from those driving compact cars. So we would say our p-value is giving very strong, statistically significant evidence that the proportion of college students driving SUVs differs from the proportion get it eventually driving compact cars. Now, what this doesn't tell us, you almost get too enthusiastic about what you want to say, but don't get overly jumpy on your trigger finger here in the conclusion. What do I mean by that? The temptation is to look at that statement and say, oh, well, they drive more SUVs. No, 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 no. The alternative didn't say they drive more SUVs. The alternative says the proportion that drive SUVs differs. So the proportion that's driving SUVs versus compact cars may be higher, or the proportion driving SUVs might be lower than the proportion of those driving the compact cars. We don't know what it is. A confidence interval would tell us, but we don't know just by looking at this and this alone. How do the formal and informal link each other together? Look at what's being said. Over in the formal, we rejected the null. Rejecting the null, we said, is the same as crossing it out and ignoring it. So if we go over to the null and reject it, that must mean the alternative is somehow probably our preferred choice. What does the informal do? The informal doesn't say anything about rejection or not of the null. The informal goes and immediately tells us how much do we believe the alternative is true. So the difference between the formal and informal is simple. Formal is a statement about the null. We either rejected it or we did not reject the null. The informal is telling us how much we believe the alternative is true. So that's the way you can think about these two as you start working them in the future. Hope this little video helps you guys. Look forward to posting more things here and guidelines on how to do these problems in the future. You guys have a good one and take care. Bye-bye.